Hello, we're going to take a look at your MT2 final affirmation right now and make sure you upload your work once you're done. I know not every problem requires work, like this first one. I don't expect to see work on, but there were a couple problems I did want to see some work on. Now on this one, when we're looking at the negation just means opposite. So the opposite of the dress is blue is the dress is not blue. You had that one correctly chosen. That's all you should choose though. When you do a negation, you either put the word not in it or you take it out if it already has it in it. So the only one is the dress is not blue. Negation doesn't mean, just because it's not blue doesn't mean it must be yellow. So that's an incorrect. You're going too deep into that one. Here's one of our proof ones that you said confused you. Not all your proofs were that far off. A couple of them you just had one reason that was wrong and everything else was right. Some of them you just gave up, I can see, because you were frustrated. So we have to work on that part. We're told B is parallel to C. Why do we know that? Because it's given to us. Because it's right there. Let's mark B parallel to C. I'm going to put arrowhead on B and an arrow on C to remind me those two lines are parallel. We're also told angle 6 is congruent to angle 4. That's also given. So I'm going to mark angle 6 is congruent to angle 4. Now let's use the fact that B is parallel to C. Since B is parallel to C, we have all these angles up here have to be congruent to the angles down here. Well, we already have angle 6. So let's use angle 6. Angle 6 would be congruent to angle 8 because they're corresponding. So you should have said angle 6 is congruent to angle 8. The reason we know that is if we have parallel lines, that tells us the corresponding angles are congruent. Now, if we don't look at the diagram but look at the proof, notice angle 6 is in two of our lines. So angle 6 is congruent to angle 4, and angle 6 is congruent to angle 8. So what does that tell me? Well, that tells me that angle 4 must be congruent to angle 8. And that's that everything is congruent property, which is transitive. So angle 4 is congruent to angle 8. Reason? Transitive. Now, if we look at the diagram, I probably should have marked angle 6 as congruent to angle 8 a while ago. Let me mark that. Notice angle 4 and angle 8 are marked congruent. If I take out, pretend line B isn't there, what kind of angles are 4 and 8? Well, those angles are alternate interior angles, because they're on the opposite side of the transversal and they're inside the parallel lines. So we're going to say, that if they're alternate interior angles, that means line A has to be parallel to line C, because now we have I don't want to write all that word out. I'm going to say, if we have alternate interior angles congruent, that implies that the lines are parallel. So you just should, that was a pulled on menu on that one, but that's the one you want to pick, just the opposite. Okay, let's take a look at this one. We have to do our own proof on this one. So we'll start with our statement and our reason. We have two givens, so we'll start there. The measure of angle QPS equals the measure of angle TPV. So I guess the kind of work I'd like to see is I'd like to see you draw this picture out and mark down. So we know Q to P to S is the same as T to P to V. That's given. And then we also know the measure of angle 3 equals the measure of angle 4. That's given. So I'll mark angle 3 is congruent to angle 4. And we want to prove angle 1 is congruent to angle 2. Well, notice QPS is a big angle. We get QPS because we can add angle 1 and angle 3. So I think that's what we're going to say. We're going to say the measure of angle 1 plus the measure of angle 3 equals the measure of angle QPS. Why can we say that? Well, we're adding angles, aren't we? That's the angle addition postulate. And we'll do the same thing for TPV. The measure of angle 2 plus the measure of angle 4 equals the measure of angle TPV. Angle addition postulate. Now remember, our first given was QPS equals TPV. Well, what I'm going to do instead of writing QPS, I'm going to write 1 plus 3. So we're going to say, oh, the measure of angle 1 plus the measure of angle 3. Instead of writing TPV, we're going to say the measure of angle 2 plus the measure of angle 4. What do you do when you write something instead of something else? Well, that's substitution. Now I'm going to look at my second given here. My second given is angle 3 is the same as angle 4. So what I'm going to do in my proof, instead of writing angle 3, I'm going to write angle 4. I'm going to write the rest of it the same though. So we're going to say, oh, the measure of angle 1 plus the measure of angle 4 equals the measure of angle 2 plus the measure of angle 4. And that's substitution again. Now notice you have angle 4 on both sides of your proof. Well, of your equation, since I proof. On both sides of your equation. Well, that means we can subtract that off. So you're left with what you want to prove. The measure of angle 1 equals the measure of angle 2. That is the subtraction property of equality, but when you on the pull-down menu, it's called addition and subtraction properties. Because you subtracted angle 4 from both sides. In order to subtract angle 4 from both sides, they have to be the same. So that's why we had to use substitution. So we have to look at what do you start with? We start with the big angles. And then I want to prove one of the smaller angles that makes that. So that's why I had to use the angle addition postulate. Let's take a look at this one. Now, this is one where I really, really wanted to see your work. Because you're close. I don't know why you got this wrong. Well, it's wrong, but I don't know your thinking that led to the incorrect answer. I don't know if you misread the problem or if you actually don't know the difference between parallel and perpendicular. Because these answers are correct, you just have them in the wrong order. Parallel lines have the same slope. Perpendicular lines have opposite reciprocals. So perpendicular should have been y minus 6 equals negative 1/9 times x minus 4. And parallel should have been y minus 6 equals 9 times x minus 4. I'm hoping you just misread it rather than you have a misapplication of the concept, but you didn't show your work, so I don't know. Okay, here's a very short proof. It should have been a short proof, I should say. Statement, reason. Given angle 5 is congruent to angle 4. On your work, draw the picture out, put angle 5 in angle 4, mark congruent. Now, when we look at angle 5 and angle 4, notice they're alternate interior angles. Oh, we're done with the proof. Since the alternate interior angles are equal, that makes the lines parallel. It's a two-step proof. F is parallel to G. Why? If the alternate interior angles are congruent, that tells me the lines are parallel. Here is a proof kind of like what we did with our angles, only it's segment. So let's write down here, statement, reason. We know QR equals RU, given. I'm going to put a tick mark. QR is the same as RU. RS equals TR, given. So R to S is the same as T to R. Now, it is kind of tough. What do you do here? Well, here's what I'm going to do. I am going to add the same thing to both sides. So what I'm going to do is I'm going to start with QR equals RU. Let's add on ORS. So I'm going to say QR. By the way, there's more than one way to do this proof. This is the way I'm choosing to do it. QR plus RS equals RU plus RS. Why? That's addition and subtraction properties. We're adding the same thing to both sides. Now, we know RS is the same as TR. Well, since RS is the same as TR in the second line, because I know UR plus TR, you can't see what I'm highlighting, UR plus TR, or RU plus TR, is that whole thing. So instead of writing RS, I'm going to write TR. So what in the third line, I'm going to say RU plus TR equals QR plus RS. Those are along the same line, so I'm going to leave those alone. That's substitution. Now look at your picture. What do you get when you add QR plus RS? Well, QR plus RS is QS. So I'm going to say that, QR plus RS equals QS. What says we can do that? That's a segment addition property. We could have written this in the proof pretty much any time we wanted to. And then we'll do the same thing. RU plus TR, well, that equals TU. Same reason. Now, let me erase one of my previous highlights. Whoops, I didn't want to do that. Let's get that back. Now, QR plus RS is QS. RU plus TR, well, that's TU. So instead of writing QR plus RS, I can write QS. Instead of writing RU plus TR, we can write TU, and that's what you're supposed to prove. And that is substitution, when you write something instead of something else. Okay, I think this is the last problem we're going to do together, and you actually got part of this right. Let's talk about what's right and what's changed. And you're going to be mad at yourself, I'm pretty sure. Start first off, QR or QS equals QR plus TS segment addition property. Perfect. That's exactly right. Okay, that one's good. TV equals TU plus UV. Segment addition property. Again. Now the third one. QS equals TV. That's not definition congruent segments. Definition congruent segment is when you change an equal sign to congruent sign. Here's why I think you're going to be mad at yourself. Look, it's given. You didn't have to do any thinking on that at all on that one. That one's given. Now, on the next one, we are taking, let me change the highlighter color. Instead of writing QS, we're writing QR plus RS. Instead of writing TV, we're writing TU plus UV. That, instead, is not segment addition, although it kind of looks that way, doesn't it? That's substitution. RU equals, or RS equals TU, that seems to come out of left field. Where in the world did they get that? Well, they get that from the given. So this should have been given. Now, the next line is correct. Instead of writing RS, we wrote TU. That's substitution. But notice what happens. Instead of writing TU, now there's a TU on both sides. So that's not definition congruent segments again. Only use definition congruent segments when you change an equal sign to a congruent sign. We subtracted TU from both sides. So that should have been addition and subtraction properties. And that's your test. So I've reopened the test to have you give it a second try. Make sure you upload your work. And the proof work should have been just draw the pictures out